Okay, cosmological stasis could explain dark matter.
Why does space have 3 dimensions? Did God only have 3 fingers to count on? No one knows. This is why physicists have for more than a century considered the possibility that space has more than 3 dimensions. This idea has had its ups and downs, but today's news is definitely an up. A group of physicists say that extra dimensions might explain how our universe grew to this enormous size, what dark matter is made of, and also make some new predictions that could be testable soon. This is because they say the additional dimensions can lead to a cosmological stasis, a temporary phase in which the universe expands but nothing in it changes. Let's have a look. If our universe has additional dimensions of space, they need to be small so that we haven't yet noticed them. They need to be rolled up to a small radius, or if you want to hear the technical term, and I just know you want to, they need to be compactified. Yes, that's also what you do with the extra dimensions in string theory, but this new theory comes without strings attached. The thing with these additional rolled up dimensions of space is that they can make one particle appear like an infinite number of particles. This is because quantum physics has taught us that particles are also waves. And if you have a particle that can extend into these extra dimensions, then its wave must go around the dimension and then fit together with itself. This means that its wavelength must fit to the size of the extra dimension, like a standing wave on a jumping rope. Right. And there are infinitely many ways to do this depending on how many periods of the oscillation you can fit in. So each time you have a particle that can go into the extra dimensions, it'll behave like an infinite number of particles. This is also called a tower of particles, and it's the main ingredient to the new theory. The authors now conjecture that one such particle exists that can go into the extra dimensions and create this tower. The details of the particle don't matter much, but it's not a particle that we have already discovered. They say that if you have any particle that creates such a tower of modes, and you start the tower out in the early universe by giving it some energy, then this energy will gradually decay down the tower. And while this happens, the gradual decay creates pressure that expands the universe very rapidly and very steadily. This is the cosmological stasis. The universe expands, but in it nothing changes. Matter doesn't clump, radiation doesn't dilute, everything remains the same until this tower of particles runs out of its initial energy. Then the rapid expansion ends and the matter in the universe begins to clump and form stars and galaxies. It's an interesting idea because, you see, physicists have long suspected that after the Big Bang, our universe must have undergone such a phase of exponential expansion. Concretely, they think it must have increased its size by more than 26 orders of magnitude within a billionth of an attosecond. And you thought pregnancy was bad. The exponential expansion is called inflation, and physicists say it's necessary to explain why the cosmic microwave background looks the way it does. I'm forever on the fence about it. On the one hand, I agree it's a useful theory to calculate some features of the cosmic microwave background. On the other hand, I'm pretty sure that it isn't the only theory that'll do that for you. The biggest problem with inflation is that we don't know what caused it, and we don't know how it stopped. And this is where the extra-dimensional particle tower comes in. It gives rise to this cosmological stasis, which is a temporary phase of exponential expansion, and that naturally stops when all the initial energy has cascaded down. Better still, once cosmological stasis stops, the particles from the tower don't disappear. They linger around and form dark matter. It's a particular type of dark matter called warm dark matter that physicists have considered before. They just didn't know what it might be made of. If dark matter is warm, then loosely speaking, it doesn't clump as well as the more common type of cold dark matter. The difference between cold and warm dark matter is difficult to infer from observations. However, the authors say that their theory could be testable in other ways. The exit from the cosmological stasis would leave behind a characteristic gravitational wave signal and also telltale signs of weird correlations in the cosmic microwave background, both of which might be measurable with upcoming experiments. So what are we to make of this? To be shockingly honest, I think this is nonsense. It's mathematical fiction, a combination of speculative ideas that make for an even more speculative idea. The most interesting...
Well, come on, Sabine. At least it is experimentally testable with upcoming experiments. So, I mean, give them that at least.
thing here is that people get paid for working on this. But what do I know? As I said, the idea of extra dimensions had its ups and downs. So maybe the real problem is that the more dimensions you have, the more difficult it becomes to tell what's up and what's down. Did you know there's a free...
Yeah, I like Sabine's explanations. I think it's a nice way of staying in the loop and deciding what papers are worth diving into. I mean, she's limited like maybe once a day or something, so, but, yeah, I think in this one, I think researchers should definitely get paid for stuff like this. I think there is a case to be made where Sabine is upset that they are paid, but she is not. And, I think sort of some of the issue is that she feels that they are paid because she is not, and my point of view is that no, they should also be paid, but you should also be paid, and it's a shrinking part of money. There should be more research funding in the West in general, so it's a larger macroeconomic issue, but yeah, but I absolutely think that research like this should be funded because it's trying to, you never know what's going to be a breakthrough and what's not. So I think it's fair enough to fund this, and I'm really happy that at least it is testable in the near future. So if it's not testable at all, like a lot of string theory, then it's kind of questionable about not whether it should be funded, but how much it should be funded, But yeah, okay. Interesting. I mean, a tower of particles. It's an interesting idea. I love it when people come up with interesting ideas like this, because it's all like you're thinking outside the box. It's it's just who knows. It's very clear that reality seems to be a lot more, I don't know, like exotic than what we currently think it is. So I like the direction of this publication, even if it turns out to be wrong. Like, publications like this help other people come up with other ideas. And so, like, I'm definitely for financially supporting groups like this. There needs to be more funding. And while it's unfortunate that Sabine doesn't get funded by academia, I think she'd be a great professor. She's very good at explaining, and she's clearly very passionate. But I'm also kind of excited that she's started down a new pathway. And, there's this... maybe academia needs to change. Maybe there's a new, before academia, there was nothing. Academia was an invention. And so maybe there's a new infrastructural development that she's following through on, in which it's, beyond academia. So it's kind of interesting.